Good. Today we are going to discuss about establishing the product function. This is a very important topic and probably we may discuss about it in 2-3 sessions. I will not be concluding this topic today. That is the crux of design. So we will be continuing for at least 2-3 sessions. So what we are going to talk about today is establishing the product function. Now next slide. Now first let us see the context. Okay. Let us get the context right. Now the voice of the customer is heard. Okay. Now we are traveling through the product design cycle. Now we are at a stage where the voice of the customer is heard and we know what we have to provide. Is it okay? You understand what we mean by voice of the customer? So the voice of the customer is heard. We really know what the customer really wants and we have decided what we are going to provide in this particular product. We have done a competitive analysis. We have positioned our product in the market. We have also broadly converted the voice of the customer into what is known as technical specification. Now what is the difference between the voice of the customer and the technical specification? The voice of the customer will only articulate the need. He will only say what he wants. Okay? A voice of the customer will probably say, I want a very good pickup for my two-wheeler. Now what is the corresponding technical specification? The voice of the customer will say, I want very good pickup. What is the corresponding technical specification? My vehicle, my two-wheeler must have acceleration characteristics, which is, say, it should have, from starting, it should provide so many meters per second acceleration. See, there are different stages. There are different steps in arriving at, in converting the voice of the customer into a technical specification. In this particular problem, it is quite simple. Good pickup. Okay. First, customer will never give you any number. Customer will not be specific. Voice of the customer will never be specific. Customer will say, my cell phone must be aesthetically pleasing. Can you ever find a number for that? Okay, how will you quantify something which is aesthetically appealing to you? No. Of course, you have to. Okay, so there are various techniques by which such subjective issues can be quantified. Probably what I will do is I will make 10 designs of cell phones, okay, form a customer pool. I will select at random, pay them on hourly basis, and then request them to evaluate all these 10 cell phones, 10 designs from the aesthetics point of view in a scale 0 to 10. You understand? Now I get some numbers for the aesthetic appeal. Now are you getting the point or am I? Please feel free to stop me if I'm going ahead of you. See, what is the difficulty that we are talking about? How to convert the voice of the customer into? Is that clear? What is the customer? Why should I convert voice of the customer into technical specification? See, from the voice of the customer, I cannot do anything as such. I cannot work with the voice of the customer because customer says something which is really abstract, okay, intangible. I cannot fix it. We have seen 2 examples. Of course, I can give you many more, but let us understand this. The first one, for a two-wheeler, customer wants what? Good pickup. Not even acceleration. That is not the term that he will use. Hey, imagine you forget for a moment, which you should not do, but I permit you to do. For a moment you forget that you are an engineering student. Okay, you should never do that. Okay, but for this exception. What will you say? Will you say, I want an accelerating characteristics of my two-wheeler to be so and so? No. You will simply say, I want a good figure. That must be converted into acceleration characteristics. Fine. You know how to do it. Okay. So, how can you do it? First, what I will do is, I will say 0 to 100 kilometers per hour in, say, 3 seconds or 5 seconds. This is what the ads say now. See, the customers are also evolving. Customers are also evolving. They are gaining more knowledge. So, they don't just go by, my vehicle will have a good pickup. They want now numbers. So, what the ads say? Advertisements say, my vehicle can reach from cold start to 100 kilometers per hour in 10 seconds or 3 seconds or 5 seconds. Depends on the brand, depends on the product. This is easy to convert. 0 to 10 seconds 0 to 100 kilometers per hour in 10 seconds. Assuming uniform acceleration, I can work out what the acceleration value is. Is it okay? This is easy to convert. Somebody says, I think in the reverse engineering lecture you heard about vehicles, two-wheelers being masculine, massive. So I want my two-wheeler to have such an appearance. How to quantify that? Now the only way you can do it, you generate an artificial pool of potential customers. You get some 20 people, 30 people who in a way represent the customer. You consciously choose. If it is for a bike, you select from college going boys. Okay. If it is for a scooty, you choose from college going girls and working women. Okay. You form a pool of artificial customers. The pool size, it is your choice. It can be from 30 to 100. Then you present to them some 10 alternatives. Ask them to rank it based on the characteristics that you want. Okay. Will they feel the appearance as manly? Will they feel very friendly? Okay. Aesthetically pleasing? They can have different criteria. Okay. So you list them and then ask them to rank. Then finally, for each design, you get a number. Sorry. This is how you convert the voice of the customer into quantifiable, because we have to work with numbers. As engineers, we are only comfortable when we work with numbers. So you have to convert the voice of the customer into technical specification. Yes, gentlemen. Can you tell me what you understand by test order? What do you understand by technical specification?
What the customer needs.
Then what is voice of the customer? Are they two different things or are they one and the same? Yes. That much is good. At least identifying voice of the customer and technical specification as two different things is good. Not good enough. Then tell me. Anyone else? Next person. But hello, I cannot hear you. What do you understand by the term technical specification? What? Hello? Next person. Tell me at least why you have a customer?
Needs of the customer.
What?
Needs of the customer, sir.
Needs of the customer. And what are technical specifications?
The needs of the customer which is met by technical.
How does it differ? What is the difference?
That's
You are right. You are exactly right. But what is the difference?
the customer doesn't know.
In a pen, what does does the customer want?
To write.
Good. First thing. The why does the customer for a pen is, I want the pen to write. Is it the only thing you want? Please sit down. Customer wants only the pen to write? Then? No. Customer will never say, I want a good nib. No. Okay, good. It should have a good grip. Will he say, I want to have a good grip? No, imagine when you are talking about pens, mostly I have to forget about college students. I have to go to, now, when do you write? I hope you write in the examinations. And that too very little. Okay. So who is your market pool? School. Which student? Mostly school students. Okay. Right? Okay, what will he say? Will he say, I want a very good grip in my pen? No, I have to. Okay. My daughter wrote an imposition yesterday and her complaint was, my hands are paining. Okay. So my hands are paining. See, this is how I have to write for 3 hours, but still I should not feel the pain. So that is how the customer will articulate his requirement. I have to write for 3 hours, but still my hands should not pain. So how can that be achieved? By providing a, why her hands are paining? Because she is holding the pen very tight. Why she is holding the pen very tight? Otherwise it will slip. She is exerting more force than that is required. A pen has 2 beautiful things to be achieved. One, it should be very dexterous. Okay, if you write Tamil especially, you have a lot of curves. Okay, and you have to move your hand. Okay, to write all these letters, you have to move your hand. Meaning, you should have a very, very fragile, very easy moving thing. At the same time, it should not slip. There must be a force balance here achieved. Force just required to hold it. Do you understand? So, if a pen has a better grip, then the hands will not pain. So, customer will always say, I want a painless writing. So don't say painless writing is no writing. No. I mean, that is not a product design. Okay, you have to write for 3 hours, but at the same time it should be a painless writing. This is how the voice of the customer will look like. But how should it be converted into? It should be converted into pen with optimally designed grip. This is what the technical spec says. Okay. So at least in the area where you are supposed to hold the pen, you provide a relatively soft material which will cushion the force, which will provide even for a small force larger deformation. Even for a small force, since it is made up of a soft material, it will deform more. Do you understand? Even for a small force, that must deform more. So that you have a larger area on which my hands will rest, my fingers will rest. And what is the mechanical property? That will give me larger deformation for very small force. Yes? Elasticity is a, okay, can you give me a specific property? Mechanical property. Yes? I'm not able to hear. Please say aloud. Deformation is what I want. I'm saying I'll apply only a small amount of force, but I want a large deformation. Which mechanical property I should look for? Huh? Refractoriness. No. Refractoriness is the ability of a material to withstand elevated temperatures. Tensile strength. Good try. Tensile strength strength is the stress value at which the material will fail. I have not talked about failing of the material at all. We will come to this particular aspect, understanding materials and developing a feel for materials later. But still, since they have started, you must try. Strain, no. Strain is the deformation divided by original length. Doesn't come near at all. You got it and then you lost it. Try again.
Yes.
Huh? It is the Young's modulus which I should look for. See, this is where all that you study, you have to study very thoroughly, then only you will be able to apply. Engineering is nothing but applying whatever you know. It is applied science. Young's modulus, it is the stress required for unit strain. Young's modulus, one way of looking at it is stress divided by strain. Or, to put it in the other way, that much we know. Young's modulus, if you ask, everybody will say stress divided by strain. Other way of looking at it is stress required to cause unit strain. What is unit strain? I have 1 meter length rod. I will apply a stress that will make it 2 meters. So increase in length is how much? 1 meter, because the original length is 1 meter. Now, the final length is 2 meters, increase in length is? So, increase in length is 1 meter, original length is again 1 meter, that is unit strain. The stress that will produce unit strain is Young's modulus. Now, I want to apply a load, at the same time, it should deform easily, means I have to look for a low Young's modulus material, which is, that is what we generally, colloquially term it as a soft material. Is it okay? So that is the material that I must go for while selecting my gripper. Are you able to trace the path, the voices the customer takes? That is the objective of the exercise that I am doing today. What did the kid say? The kid said, I am going to write for 3 hours, but still my fingers must not pain. This is a typical voice of the customer. Now, how we are going to react as a product designer, how we are going to react to this voice of the customer, that is what we are discussing right now. This voice of the customer must be translated into technical specifications and, as we are going to see, into some function of a product. We will do this iteratively many times. Probably in that way you will be able to gain some better understanding of what we are trying to do. Is it okay? Now, VOC is converted into a broad technical specification. Now the question is to realize the technical specification. Okay, it is easier said than done. But the job of the engineer is to get things done. So, now the question is to realize the technical specification. Now, what we have to do is, we have to generate various concepts to achieve that particular function. What we are going to discuss now is what are the various concepts that will achieve a particular design functionality. Next slide. Now, before we proceed further, I want you to appreciate the idea of a system. Yes. Make on like that. எல்லாருக்கும் கேக்குதுங்க. ஓ இங்க சிக்னல் வரலையா? சரி. Is it okay? Sorry. Now, what we have to see is, we have to see the concept of system. Okay. is a very useful thing. Okay? Because this approach we are going to deploy in many instances. So we have to understand the idea of system very thoroughly. Now, system is anything which receives certain inputs and then provides certain outputs. System is something which has a boundary. Okay. I have certain inputs and system will provide certain outputs. Okay. Anything can be viewed as a system. Generally, there is something called, a separate subject called systems engineering. Systems engineering teaches you about a systems approach. A systems approach. This is one way of analyzing different scenarios. Okay. Now system is something, system has a definite boundary. It receives certain inputs and then it provides certain outputs. Okay. Let us see. Let us come back to the slide later. Can we go back, go to the next slide? Right. Now in our context, one thing is to understand systems in general, because many people have already started wondering, sir, what should I study about system? So in our context, let us study the relevance of a system. Then we will go back and then study systems in general. See, all products, they do some job. They fulfill certain functionality. So they accept certain inputs and then they provide certain outputs. So all products can be viewed, visualized as systems. So we can model them as system. Not only products, even parts, sub-assemblies, sub-assemblies, everything, they receive certain inputs and then provide certain outputs. So anything that you want to analyze, that can be viewed as a system. It can be a simple component, it can be a full product, or it can be a sub-assembly or an assembly. Anything can be visualized as a system. Now next slide please. Now there are different flows that are taking place in the system. There are different flows that are possible in a system. I am trying to be very, now I am talking about very general system, but these are applicable to products, assemblies and sub-assemblies also. Now generally, can we go some 2 slides back, sir? Now, the input, what is an input? The input can be some material. The input can be some energy. The input can be some value. The input can be some signal. Okay. Accordingly, there will be outputs. Let me take, see, the human body is a system. Is a material flow taking place through human body? Yes. There is material flow taking place through human body. What are the material flows? I just drank some water. So that is one material flow that took place. I had my breakfast. That is another material flow that is taking place. There is going to be accordingly material outflow too. I sweat. Okay. I excrete. These are material flows that take place through human body. Are you able to visualize? Something is coming in, something is going out. One thing. Now, is there any data flow? My human body is a system. Imagine a boundary drawn very rigidly through my contour. A 3-dimensional. So that is what the black line here indicates. Now what is the black line? A 3-dimensional contour around me. Is it okay? So is there any data flow that is taking place? Yes. There are various, all my sensory organs, they do perceive and then they provide some data in. What is the data in? I see somebody talking there, I have to respond accordingly. Okay. I see somebody nodding, so I must feel that I'm proceeding in the right direction. I see somebody sleeping, then I must sense that, no, this is time to crack some joke, to wake them up. Okay? So, I feel the heat, all my sensory systems, they provide data input. Are there any data output? I suppose so. Otherwise the whole exercise will be futile. I presume that there is some data output taking place from me. Okay. Now, this is the data flow. So there is material flow, there is data flow. Okay. Then what else? What else that slide talk about? There is energy flow. Is there any energy flow taking place? In the form of material, why do I eat? I mean, in fact, there is a material energy conversion taking place in my system. I eat primarily because I need energy. Different types of, essentially I eat because I need energy. The main purpose of our digestive system is to generate energy. All the carbohydrates, okay, like your fuel. What are fuels? What are the chemical characteristics of all the fuels? Can you give a chemical generic name for all the fuels? No. Hydrocarbons. All the fuels are called hydrocarbons. Okay. All the fuels you can take from me, they contain either hydrogen or oxygen. Some of the hydrogen or carbon. Some of the biofuels will contain some oxygen elements also. Okay. So the hydrogen is burning, converted into water. So that is an exothermic reaction generating energy. Carbon undergoing combustion, undergoing an exothermic reaction generating energy. So similarly, what is the main source of our food? Carbohydrates. Again you have the same carbon and hydrogen elements present. Why? Why are they present? Through my body metabolism, they are converted into, my metabolism essentially converts again this carbon and hydrogen, okay, into energy so that it can be used by various parts. Now, so there is an energy mass conversion taking place within the system. So part of the mass is converted into energy. Of course, this energy is sent out of. Okay. Now, let me go back. Yes. So, the flow of material in general or matter, flow of energy takes place across systems. The flow of information or signal takes place across the system. Then, I'll come to the last point later, flow of value or money. This is applicable primarily to economic systems. Okay. And we have to talk about this in engineering systems also. I'll come back to this later. So anything can be viewed as a system. See, this microphone can be viewed as a system. Okay. I can view this alone as a system. So this alone can be viewed as a system. What is the signal coming in? My voice is the signal coming in. What is the signal going out? Electrical signal is what is going out. And this is my system now. This is my system. What is the signal in? The vibrations produced in the air because of my voice. That is the signal in. What is the signal out? Electrical signal, which is subsequently amplified and then sent back. No, is there energy flow in this? Yes. To convert my voice into electrical signal, it needs power. So that power is flowing in. It has few batteries inside. Okay, inside this you have few batteries. So the power is provided to this transducer to convert my electrical, to convert the sound into electrical signal. So, to analyze everything in detail, you resort to what is known as a systems approach. This is very, very useful. Okay. We will use this in our value analysis. That is the way I have introduced this. And also, there is value or money. This is useful in analysis of economic systems. Next slide, please. Now, why we require functional decomposition? What I am going to do, is the customer wanted so many things. The voice of the customer said so and so, so and so, so and so. Now I am going to convert all the voice of the customer into some chunk, which represents a particular functionality. Now let me put it like this. What I am going to do is, I am going to suppose say this is my product. This is my product. Let me take an example. So the product I am talking about, say it's a two-wheeler. The customer said, one thing the customer said was good pickup. So this is my full product. The other thing the customer wanted was good mileage. Definitely. Okay. The other thing the customer said was manly appearance. Is it okay? Another thing the customer wanted was he wants the product to have some masculine characteristics. Okay. Then the another thing the customer wanted was he didn't talk about cost. He wants to spend. Okay. My bike must be very cheap. Okay. Then another part he wanted was good policy. Good code stock means, of course, people in Chennai may not recognize it. Okay, in winter, your bikes generally, they pose a problem. Probably it could have happened a month back in Chennai. Okay, even now, it is very chill in the morning. It's not a problem in Chennai at all, but it's a big problem in cold places. You don't know how big the problem is. We in Chennai, we really don't know how good the problem is. I see few people smiling because they should have realized the problem. Good cold start. In US and EU, it is a very big issue. So the customer wanted something else. Now what I have done is, I have all these functionalities put together. Please remember, the customer will never say, I want an engine. Customer will never say, I want an engine. But obviously a bike should have an engine. Only an engine can provide a good pickup and all that. But that is not the concern of the Okay, it should be able to stop instantly, preferably, or say that has to be converted into a technical specification. Now what I have done is assemblage of all these functionalities is my product. I am not talking about physical assemblage here. These functionalities put together is my new product. Like this, can you do for every product? Every product, if you hear the voice of the customer thoroughly, you can convert all these customer requirements into function. Now, the functional decomposition is nothing but viewing a product as an assemblage of these functionalities. Functional decomposition is viewing a product. I repeat again, functional decomposition is viewing the product as an assemblage of all these customer requirements. You view the product as a product having good pickup. Okay, it should be manly, it should be cheap, it should have a good cold start, it should have good braking characteristics, it should have good mileage. You put everything together. Please remember, it is not a physical assembly. It is I am saying it is a functional assembly of all the customer requirements. Why I am not saying physical assembly? No, the customer didn't talk about tire, he didn't talk about wheel, he didn't talk about engine, he didn't talk about fuel tank. No, please take it from me, he will never talk about all these things. That is not his concern. For every product, that is the coordination of the product designer, that is the job of the engineer. Customer doesn't know where the engine is. I hope all my students know. In a two-wheeler, where the engine is. Okay, you should. Okay, but the customer may not know. Please take it from me, the customer may not know where the engine is, where the carburetor is. No, he is not interested. Okay, he will not know and he is not bothered. Okay, if you ask him where the brake is, he will show the handlebar. Okay, is that the place where the brake is? No, because for him the brake is in the handlebar. Please understand, this is what I mean by functionality. All that he knows is, if I press this, the vehicle will stop. The engineering part, you call it as a brake, that is located somewhere else. He is not bothered. Now what I am talking about now is the functional decomposition of a product, which is different from physical decomposition of the product. In reality, a product consists of engine, wheel, steering. Okay. Then what else? Carburetor, cables, frames, all this, seat, tires, rim, all this physically assembled together constitute a two-wheeler. But I am talking about an altogether different ballgame. What is it here? I am functionally dividing my product into different categories and viewing the product as assembly of these functionally decomposed. Why should I do this? That is what we are going to discuss now. Have you taken down this? Okay. Why should I do this functional decomposition? Are you able to understand the physical assembly and the functional assembly? Physical decomposition and functional decomposition. What is a physical decomposition? What we do in design appreciation lab is physical decomposition. You dismantle everything. But what you should do in the design appreciation lab is functional decomposition also. I'll come to that later. Now why should I do functional decomposition? Because functional decomposition talks about what rather than how. Now, generally, I tell my students whenever they come to me for counseling also, I tell them, you first decide what to do. At that point of time, don't bother for the time being how to do it. We will talk about how later. First, what you should talk about? You should talk about what to do. See, as an engineering student, what you should do? You should gather engineering knowledge. So for that, what you should do? You should at least work for. You should study new things. You should learn new concepts. At least for 3 to 4 hours every day. This is a priori. This is something which you must decide independent of how you are going to do it. How comes later? As an engineer, as an engineering student, I will do justice to that functionality only if I learn new concepts every day for 3 to 4 hours. It is independent of how you do it. How you do it can be done in 100 different ways. It can be done by sacrificing your sleep. It can be done by reducing your game time. It can be done by sacrificing your cell phone conversations. It can be done by sleeping less or playing less. This is indifferent. You should not confuse how and what. What must be decided first, and then you should start working on how to do it. If you confuse that, sir, how can he study for 4 hours? I don't have time. If you confuse that with what, you will end up nowhere. That is not a scientific approach. Similarly, while designing a product also, what should be your starting point? What should be achieved? At that stage itself, if you start worrying, how can this be achieved? This is a very tall order. How can I achieve an acceleration of so much? How can I achieve a fuel efficiency of such a high value? If you start worrying about how at that stage, you will go nowhere. So, functional decomposition is good because it relieves you from the pain of how. It doesn't ask you the question how you are going to do it. That question is going to be asked later. You are only going to answer that question also. How you are going to work for 3 or 4 hours? Will some messiah come and give you the answer? No. That answer you have to find. But what that I'm saying is, first you decide what. After that, you take up the question of how. Do you understand? Functional decomposition gives you the thinking discipline. It is only a thinking discipline. It is only a disciplined way of approaching a particular problem. This is the scientific way of approaching a problem. First talk about what? Decide. And then worry about how. In all your problems, in all your day-to-day activities, at this particular juncture, what I should do? You decide first. And then you can decide how that can be accomplished. First you should decide. I should listen to the class. Then you can worry about how to overcome the sleepishness, how to overcome the temptation by your neighbor. All that will come later. But what should be the first thing? What? Similarly, in product design also, functional decomposition enables you to divide what are all the functionalities to be achieved. That gives you an opportunity to worry about how later. It provides a basis for dividing the product into functional chunks. The product can be divided in many ways. A product can be divided in many ways. Physically, what I can do, I can take a hammer, break a product into 100 chunks. If you want 10 chunks, of course, I can divide it into 10 chunks. But how do you want to divide a product? You want to divide a product into functional chunks. I'll show you a better example, okay, in the later part of my presentation. Okay, what do you mean by functional chunks of a product? Now, why do I want to divide a product into functional chunks? I want to divide the product into functional chunks because I know what functions my product has to perform. See, you should view the design as a logical flow of things. We have started from the voice of the customer. Now I know what the voice of the customer said. What is the next easy logical step? Immediately you map the voice of the customer into functions that are to be performed by my product. Now then, another important advantage is the creativity is enhanced. The creativity is generally enhanced when you provide a small piece of challenge rather than a big piece of challenge. When I decompose and provide you a more focused problem, your creativity is stimulated. Your creativity is stimulated because when you pose a big question before you, your mind momentarily might get puzzled by the magnitude of the problem and it may not be very creative. But when I pose a smaller problem, when I pose only the chunk, your creativity is likely to be enhanced. Next slide, please. Another important advantage of functional decomposition is it is a very natural form of abstracting the design task. That is a design task. It has to be performed. So it is a natural way of decomposing it. So since the customer needs are mapped into functions, it enables you to multiple solution generation. Now we have to come to, after functionality mapping, we will go to what is known as solution generation. What ultimately you want is multiple alternatives that can solve a particular problem. Multiple alternatives that can solve a particular problem. That is well done when you do the functional decomposition. Then we have already settled one issue. We are going to follow what is known as concurrent engineering approach in our design. What is concurrent engineering approach? What is concurrent engineering approach? What is the other engineering? Sequential engineering. This is concurrent engineering. What is sequential engineering? One word, one phrase. One after other. Don't say step by step. It is one after. That's what we meant. Okay. Sequential engineering is one after another. What do you mean by one after another?
One process after the other.
Give me an example. Pardon? No. Here we are talking about the product life cycle. In the product life cycle, in product design, how we are going to approach product design? Concurrent engineering is simultaneous engineering. Here, what we are talking about, concurrent engineering is applied to where? In product design. In product design, design, can you tell me what is sequential engineering and what is concurrent engineering? So first, okay, you have a design, then you plan for tools, you manufacture, you assemble, okay. Okay. So in manufacturing, if you are having a problem, then you go back to design. In assembly, you have a problem, then you go back to design. This is what we mean by sequential engineering. In concurrent engineering, you have a design team which does the job, which will look into manufacturing issues, which will look into assembly issues, which will look into the analysis issues. So everything is done by a team rather than throw over the wall approach. Throw over the wall is to do something and then throw over the wall to the next person. Okay, then it will come back again. So that's why that is not very useful. We have seen it. Do you remember? Okay. Now the concurrent engineering approach can be practiced easily when you do the functional decomposition of the software. When you do the functional decomposition, the concurrent engineering approach can be adopted easily. Can we go to the next slide? Now this is what I wanted to show you. These are the various subsystems of an automobile. Okay, these subsystems are functionally different. See, I didn't divide the automobile into, say, I didn't take a huge knife and then cut the automobile and then cut it. It is not done like that. For example, if you take the transmission system, where does it start? Yes, transmission system, it starts from the engine output. Okay. So here you have the gearbox, here you have the propeller shaft, you have the differential, you have the axle, you have the rear axle. The entire thing is the transmission system. Let us take something more interesting. Let us take, say, exhaust system. Exhaust system, where does it start? It starts from the engine, exhaust manifold. This is the engine exhaust manifold. Okay, what is an exhaust manifold? No, I don't see any bright eyes. That gives me a feeling I am talking French. Okay, what is an exhaust manifold? Hey, you are cutting open an engine and then seeing it. Still you are not able to say what is an exhaust manifold. See, you have exhaust valve, you know. Exhaust valve, you know. So, exhaust valve, where does it open? Does it open to the atmosphere? No. You have a multi-cylinder engine. Typically you have a multi-cylinder engine here. So each cylinder will have its own exhaust valve. All the exhaust gas is to be collected by a single unit. That is called an exhaust manifold. Okay. So all the exhaust valves will open into an exhaust manifold. So all the exhaust gas, they are collected by the exhaust manifold. That is what is shown here. Now the exhaust manifold, from that it goes to, what is this? This is a catalytic converter. What essentially a catalytic converter does? It converts carbon monoxide into, then carbon into carbon dioxide. We have some noble metals here which are catalytes, okay, which are catalysts, which will promote the complete oxidation and which will eliminate, which will minimize the pollutant. Okay, then you have the silencer or muffler. Muffler is essentially a Essentially a muffler is essentially a sound arrestor, it is a silencer. Okay, it controls the velocity, and then you have a tailpipe through which the gas goes. So does it map a particular functionality? What is the functionality here? Of course, the customer will not say it in so many words. Okay, but the exhaust gas is to be sent out. Okay, without producing much of noise, without disturbing the atmosphere or disturbing the atmosphere minimally. The exhaust gas is to be sent out. This is a functionality. This is achieved by the exhaust system. Okay. So, like this, you have many functionalities. You have a suspension system. Is it okay? Now, I am almost close to the end of the lecture. We will view the different subsystems of the functional subsystems of an IC engine, and then probably we will close for the day. So these are the various subsystems. Okay, whatever we have talked about, you would have seen. So this is the ignition system. So what do I know? I have a spark plug here. That spark plug needs to get the voltage so that there is a spark appearing there. So how the voltage is generated? So you need an electrical system. So you have an engine. You have in the engine you have a generator, you have an alternator. The energy is generated and it is stored in a battery for starting and all the requirements. Then you have the ignition switch. This is the starting motor. That is an altogether different thing. Okay. So this is the electrical system. Can you hold it for a moment? This is the entire electrical system. Your fuel ignition system is part of a larger electrical system in the automobile. What is the functionality of an electrical system? So to start the engine, what do? You will do in the thermal lab, you have to crank the engine to start. All the IC engines, they have to be cranked. Okay. So that we cannot do it. The earlier automobiles, we did the cranking. But now we want the electrical cranking to take place. That means the internal combustion engine will be started by an electrical motor. So you have a starting motor. The starting motor is an electrical motor, so it needs power. So what you do is, from the mechanical energy available is to be converted into electrical energy by the alternator and stored in a battery. So you convert the mechanical energy, part of the mechanical energy into electrical energy in an alternator and then store that in a battery. Now this may supply, the electrical energy may be supplied for the starting. It can be used for your refrigeration, air conditioning requirements. It can be used for your dash panel. It can be used for lighting. So it can be used for all the electrical system. Will be used for all the things, and it will also be used for providing the sparks to the cylinders. Next. Then comes the drive system. So engine is generating the power, mechanical power, and how it is done? Can you hold it? So here you have something called a flywheel. Why do you need a flywheel in an engine? See, if it is a 4-stroke engine, you have power generators only once in 4 strokes. For all the remaining strokes, you need some power to be supplied to the piston. The piston has to compress the gas. The air fuel mixture, with the petrol engine, the air fuel mixture needs to be compressed. For compressing, you have to spend energy or you will get energy. For compressing, you have to, where will that energy come from? It has to come from the exhaust stroke only. So, during the power stroke. During the power stroke, some energy was generated. That energy needs to be stored temporarily somewhere. And then, when the piston requires that, it needs to be supplied. During the exhaust stroke, the high pressure burnt gases are to be pushed through the exhaust valve. Will you require energy for that or will you get energy from that? You require energy for that. That will you get it? Again from the flywheel. You have a huge mass which keeps on rotating. That provides, that stores the energy obtained from the power stroke, and that is provided back when the piston needs that. So that is the function of a flywheel. So then lubrication system. There is a lot of relative motion taking place. Okay, many places they require lubrication. You have bearings, you have piston and cylinder, okay, and you have all the journals. And you have many rotating parts, right from valves. Rotating, reciprocating parts. Valves are reciprocating parts. You have many rotating and reciprocating parts which needs to be lubricated. That is done by a separate lubrication system. So there can be various flash lubrication, all that. Then there is more heat generated than the materials can withstand. So there must be some way to cool the cylinders. There must be some way to cool the cylinders. This is a water-cooled engine. So the water is coming over the water jacket inside the cylinder head. So the water is circulating inside the cylinder head. That poses everyone is a challenge. So how can I have a cylinder and then some water jacket around it? So every cylinder, even in your two-wheeler, it is an air-cooled system. Any heavy vehicle engine cylinder, it has a water jacket. Meaning, this is the cylinder cavity. I must have a water passage around the cylinder to cool the cylinder cavity. So that makes a lot of difficulties for the product design. How will I make it? How will I make a water cavity here, a water passage here? So that has to be that puts a big restriction. The cylinder block, it must be manufactured. It is manufactured only by casting, metal casting, because very intricate shapes, okay, can be manufactured by metal casting only. So hole for the cylinder and hole for the cylinder liner and the water jackets, it can be manufactured only by casting. So the water is coming into the water jacket and then it goes out as hot water. But that hot water cannot be recirculated again. That hot water is to be cooled. So that is cooled in a in a radiator, okay, wherein a fan blows air over the hot water which is passing through the tubes, so that hot water is cooled and then sent back to the water tank. So this is the cooling system for the cylinder. So this is another functionality. Okay, next. Then comes the exhaust system. I have talked about it. So you have the catalytic converter, you have the muffler. Then finally you have the tailgate. Then you have the braking system. You can have various So, this is what we mean by functional decomposition. By the functional characteristics, the whole system is divided into many subsystems. This is what we mean by the functional decomposition. How to do it in a scientific way, how the functional decomposition can be achieved, okay, we will discuss in the subsequent classes. Before I wind up my lecture, I want to show this next slide, please. So this functional mapping is please don't think that this is done for only engineering systems or this is a general principle which can be applied to many domains. In fact, one of the international projects, there are many international scientific inquiries which are going on. Okay. Anybody heard about CER, sir? Yes? Can you tell about it? What is CERN? Where is it located? Switzerland, France border. Okay. What is that? What is the basic equipment you have there? Okay. It is very good. It is one of the international projects. Okay, which is being done by India is also a partner to it. You have international scientific community, okay, doing fundamental research on the very nature of atoms. It is supposed to provide data about various subatomic particles, even the origin of universe, how the universe came into being, and it is also it is taking up one of the frontier issues in engineering, meaning what is the relation between the matter and the energy. Matter can be converted into energy. Who said that? Fine. Matter can be, by destroying matter I can generate energy. But the biggest question that is puzzling scientists in explaining the origin of the universe is how the matter came into being first. Of course, religion has a very easy, safe answer. Okay. But scientists are not satisfied by that. So how the matter came into being? So the question is, it reduces to, can energy by some means, can it be converted into matter? Okay, man have demonstrated very clearly that matter can be destroyed and converted into energy. But can energy be in turn? Is it a reversible reaction? The question is pretty simple. E is equal to mc square, is it a reversible reaction? Huge concentration of energy if I could provide, can it be converted into a few milligrams of matter? I mean, CERN is doing a lot of scientific study. You can go to their website and see they are doing. They have a brilliant website because they have generated the culture of resource sharing, because unless you do that, international research cannot be carried out. And nobody is thinking of patents at least. And the commercial interest will come later, not now. So CERN is doing many fundamental research and they are asking many such questions. Okay. You should go to the website and then see. Now, another international project of this magnitude is the human space. They map from the chromosomal level, okay, from the gene level, they map the species. The different species is what? Being mapped. What is that project called? Leave it to you. Fine. Okay. Now what I am talking about here is brain mapping. What is brain mapping? You have your brain, everyone has, every organism has. And can you attribute some functionality to some parts? Now, I have consciously chosen a slide which doesn't name the different parts of brain. Okay, I haven't named them. Even I don't remember them. But please remember, the different functionalities of the brain can be attributed to different locations. This much is well known. Okay. Now, this is the region attributed to vision. Okay. This is the region attributed to face recognition. Okay. If that part of my brain is damaged, then I won't be able to recognize my daughter today evening. You understand? That is the part responsible for face recognition. Touch and pressure, taste. Okay, motor control, speech, smell, hearing. This is only a very general categorization. It can be further divided. Okay. The interneural connections, they are mapped nowadays. The interneural connections. How the brain can store so much of information. Which information is stored in which neural connection? Even to that extent, okay, the brain mapping can be done. So what I'm trying to, but please remember, the real challenge here is you are mapping a highly non-linear system. While doing the brain mapping, you are mapping not a simple linear system. What do you mean by a linear system? A linear system is something where the cause-effect relationship is pretty obvious, pretty simple. There are a lot of non-linearities associated with it. And please believe me, mapping of such systems are also possible and people have done it already. Next slide please. This is the cross-section of the brain. And the image can be viewed at various resolutions. These images are available in the public domain. This can be viewed at various resolutions and we can say what that particular region is responsible for. Okay. Probably somebody can open up my brain and then say the image of your daughter is stored here. To that extent brain mapping has become possible. Next slide please. So this website is very interesting. I think I have given that website. Somebody can note down www.brainmapping.org. Okay. interested people can visit and then see. All that I am trying to say is, functional mapping is not restricted to linear systems alone. Even highly non-linear systems such as human brain can be, functional mapping can be done. Is it okay? Now please take down your third weekly assignment. Please take down. I am not prepared. Generate the voice of the customer for the following products. Maximum 2 page. Generate the voice of the customer for the following products. Zero and 6, cell phone. And I'm sorry, it should be 0 and 4. I did the same mistake last time also. 0 and 5, 1 and 6. 1 and 6. Two and 7. Maximum page restriction is 2 pages, but let it be, you just think and then write. Articulate the voice. Are you able to understand all the products? The products are here. So what the customer articulates, please position yourself in the place of the customer. Don't write the voice of the customer as an engineer. Okay, position yourself in the place of the customer and then you say what the customer expects in a cell phone, in a car, in a newspaper, in a video game, and in a good Tamil movie. Okay. Good.